Hello and welcome again to another video. In this video we're going to solve some exercises in the differential equation. So let's get started. And these exercises we don't know now as you know that we have seen some types of differential equation of the first order. Now in these exercises we don't know which one is a homogeneous and which one is linear and etc. So we're going to solve by using the techniques to determine whether if it's an exact or if it's a linear or if it's written in the form of Bernoulli, so it's Bernoulli, etc. So let's get started with the first example. As you can see here, we have x plus 4 over the square root of xy is going to be equal to y prime. The first step that you need to do is to think if it's a separable differential equation. But what should we do first? We should replace y prime by dy over dx. We're going to get dy over dx is going to be equal to x plus 4 over the square root of xy. As you know that the square root of xy is going to be the square root of x times the square root of y. Since we have only the multiplication and the division, the first thing that you need to think about, which is a separable differential equation, and it is. So by multiplying the equation by the square root of y, we're going to get square root of y dy over dx. We're going to get x plus 4 over square root of x. So by multiplying by dx, we're going to have the square root of y dy is going to be equal x plus 4 over the square root of x dx. So as you can see, this is a separable differential equation. So by integrating both sides, we're going to get the solution. By integrating both sides, we're going to get the integration of the square root of y is going to be 2 over 3 y to the power of 3 over 2. We're going to get 2 over 3 y to the power of 3 over 2. It's going to be equal to x over the square root of x is going to be the square root of x. So it's going to be the same, 2 over 3 x to the power of 3 over 2. And we have the integration of 4 over the square root of x. So it's going to be 4 times the x to the power of minus 1 over 2. By adding 1, it's going to be 1 over 2. So it's going to be x to the power of 1 over 2. So we're going to get 4 times 2 is going to be 8 x to the power 1 over 2. And we don't forget the c plus c. And we are done. This is the solution. So let's see the second example. Since we have y prime is going to be equal to y times cosine x plus sine x. So let's think if it's a separable. Yes, it is a separable. In general, in separable differential equation, we're going to have division and multiplication only. What I mean by that, multiplication between x's and y's, I'm not talking about the x's by themselves. So if we have an addition here, doesn't matter since it would not be changed since we have y times something that is related to x. So by dividing the equation by y and multiplying by dx, we're going to have y of 1 over y dy is going to be equal cosine x plus sine x all times dx. So in this step, by integrating, we're going to have the absolute value of ln, the absolute value of y is going to be equal, the integration of cosine is going to be sine x, and the integration of sine is going to be minus cosine x, and plus c. So this is the solution. Let's see the third equation. As you can see here, it doesn't seem that it is a separable since we have a addition or we can say a subtraction between the y's and the x's. When I was talking about the multiplication and addition, it can be between the x's by themselves, but as you can see here, it is between the y's and the x's and the same as here, so it's not a separable differential equation. So let's see if it's a homogeneous. So by replacing every x by tx and every y by ty, we're gonna get here t squared, and here is gonna be t squared as a factor, and in this side is gonna be t squared, and here is gonna be t. So we cannot factor out t squared. We cannot get t squared as a factor, so it's not a homogeneous. So let's see if it's an exact differential equation, and actually it is by checking the derivative of, let's call this mx. I'm not gonna write it over, okay, let me write it down. It's gonna be the derivative of 2xy minus 3x squared over dy. It's gonna be 2x, and if it's gonna be equal to the derivative of x squared minus 2y over dx is gonna be also 2x, so it is a exact differential equation. So, and we know how to solve an exact differential equation. So we're gonna get from the first equation, we're gonna get 2xy dx minus 3x squared dx plus x squared dy minus 2y dy, we're gonna get, it's gonna be equal to 0. So by taking minus 3x squared dx and minus 2y dx to the other side, we're gonna obtain 2xy dx plus x squared dy is gonna be equal to 3x squared dx plus 2y dy. So as you can see here, this is the derivative of the product of two functions, as we said before, which is gonna be, sorry, where is the derivative between 2x and what is the primitive between 2x and x squared? It is x squared, so we're gonna write x squared, and between y and 1, it's gonna be y. So, and in this side, we're gonna obtain the derivative of x cubed plus the derivative of y squared. And by integrating both sides, we're going to obtain x squared y is going to be equal to x to the power of 3 plus y to the power of 2. So we can keep it as it is, and yes, we should keep it as it is, sorry, since we cannot have y by itself, since we have y and y squared. And let's see the third example. As you can see here, y prime plus 3 over xy is going to be equal to 6x squared. As you can see here, it seems that it is a linear differential equation since it's written in the form that we have seen. So what should we do? The first thing, if y prime by itself, yes, and here something related to x, and we should count mu. Let's count mu. Mu is going to be equal exponential of the integral of 3 over x dx. So it's going to be exponential of 3 ln x. So it's going to be x to the power of 3. So by multiplying by x to the power of 3, we're going to obtain x to the power of 3 y prime plus 3 x squared y is going to be equal 6 x to the power of 5. So as you can see here, this is the derivative of the product of x to the power of 3 times y, all prime, is going to be equal 6x to the power of 5. So by integrating both sides, we're going to obtain x to the power of 3y is going to be equal 6x to the power of 5, it's going to be x to the power of 6. plus c. Sorry, I forgot to add c right here. So we can add c. So as you can see here, this is the solution and it's quite easy. Yeah, it's easy to solve a linear differential equation. And let's see the fifth example. It said y prime plus is going to be equal to x squared exponential y. And this, it doesn't seem that it is a linear. It's not written in the form that we have seen. It's not a exact differential equation, since uh, if we get we cannot get the derivative that the thing is multiplied. We are not getting the derivative that they are equal. So if it's a, let's see if it's a separable. As I told you, the first thing that you need to do is to see if it is separable. Yes, it is a separable, since when we multiply by y to the power of minus 1, we're going to obtain x squared by itself in a side. So it is a separable, so we're going to get y to the power of minus 1 dy is going to be equal to x squared dx. So by integrating the both sides, we're going to obtain the integration of exponential minus y is going to be exponential minus 1 minus exponential of minus y and the integral of x to the power of 2 is going to be 1 over 3 x to the power of 3, and we don't forget c. As you can see, it is a easy and simple. So let's see the sixth example. It's a dy over dx minus ln x over x. Y is going to be equal to 0. As you can see, this is a type of linear differential equation, but as I told you, that the first thing that you need to see if it is separable. Since this equation we can solve it at least by two ways. So let's see if it is separable differential equation. We're going to get dy over dx is going to be equal ln x over x y. So by dividing the equation by y and multiplying by dx, so we're going to multiply by 1 over y dx. We're going to obtain 1 over y dy is going to be equal ln x over x dx. So it is a separable differential equation. By getting the integration, we're going to obtain ln absolute value of y is going to be equal, and the integral of ln x over x is going to be the same as the integral of f prime of x times fx dx, and this is going to be 1 over 2 ln squared x. So we don't forget c. So we can get y by itself, and you know how to do that, some simplification. Let's see the seventh example. And as I told you, we can solve it by another way, which is a linear differential equation. The seventh example says solve the differential equation. Of course, as you can see, the form of this differential equation, it's linear, since we have y prime plus something multiplied by xy is going to be equal to something related to x. So let's calculate mu. Mu is going to be the integration of exponential of the integration 2x plus 1 over x dx. So it's going to be the integration of 2 plus 1 over x all times dx. So it's going to be exponential 2x plus ln x. Or in this step, I'm going to keep it as it is, and I will do some simplification later. So by multiplying by 2x plus exponential 2x plus ln x, we're going to get exponential 2x plus ln x y prime plus 2 times 1 over x exponential 2x plus ln x y is going to be equal exponential minus 2x and plus 2x is going to be equal to 0. Exponential ln x is going to be equal to x. As you can see here, it is the product integral. It is the derivative of the product of exponential 2x plus ln x, y all prime is going to be equal to x. So by integrating the both sides, we're going to obtain exponential 2x plus ln x, y is going to be equal 1 over 2x squared plus c. So by multiplying by the inverse of this, we're going to obtain y is going to be equal to 1 over 2x squared plus c all times, as I told you, exponential. Let's simplify this. It's going to be equal to exponential 2x times exponential ln(x), which is x. So we're going to obtain this form. Here I'm going to write x, and here exponential 2x. And this is the solution for this equation. Let's see the eighth example. Eighth. We have dy over dx exponential x minus y plus x squared exponential minus y. The first thing that you need to do to see if it is separable. So we need to separate x and y's. So to remove all the y's from this side, since we have minus y and minus 1, so we need to multiply by exponential y. So we're going to obtain exponential y prime. Let's keep it as dy over dx is going to be equal exponential x plus x squared. So by multiplying by dx, we're going to obtain the following. So this is going to be times dx. As you can see here, it is a separable, so by integrating the both sides, we are going to get exponential y is going to be equal to exponential x plus 1 over 3 x to the power of 3 plus c. And this is an easy one, yes. And let's see one more or two. And what we have x times y squared plus x dx plus y x squared dy. So as you can see here, this is not, it's not going to be a separable since we have a plus between the x and the y's, and it's not homogeneous since if we replace this is going to be t to the power of 3 and here is going to be t to the power of 3 and here is going to be t, so we cannot get t to the power 3 as a factor to return to our the first equation. So what should we do? We should think if it's a exact differential equation. So by getting derivative of this with respect to y, we're going to obtain yes, with respect to y, we're going to obtain 2y, and here by respecting to x, we're going to get 2x. Sorry. Here, what was? It was y squared, yes. So by getting the derivative of this quantity with respect to y, we're going to get 2yx. Yes. And this by respecting to x, we're going to get 2xy. So they are equal, so it is an exact differential equation. And you know how to solve by using the method of grouping. So everything that it is related to x by itself or y by itself in a side and all the other things in the other side. So we're going to obtain xy squared dx plus y x squared dy is going to be equal minus x dx. So by integrating the both sides, or first we should so here we have y squared and here we have x squared. So the derivative of, so we're gonna search for the derivative and the, so by multiplying the equation by 2, since you cannot see that it is a derivative, so we're gonna get So by multiplying by 2, we're going to get 2xy squared, here 2xy squared, and here 2yx squared, so which is the derivative between x squared and y squared, all prime is going to be equal to minus 2x dx. So by integrating minus 2x dx, let me write it down. So it's going to be, by integrating, we're going to obtain x squared y squared is going to be equal to minus x squared plus c. By dividing by x squared, we're going to obtain the solution, and getting the square root plus minus the square root, you're going to get y by itself. So let's see, I think, the last example to solve. What we have y prime plus y is going to be equal x times y to the power of 3. As you can see here, we have y to the power of 3, and as you know that we have seen y to the power of 3 in Bernoulli differential equation, since we have y and y prime and y to the power of n, the equation. So by dividing the equation by, or multiplying by 1 over y to the power of 3, we're going to obtain y prime over y to the power of 3 plus y to the power of minus 2. It's going to be y over y to the power of 3, so it's going to be equal to x. So let's substitute u is going to be equal y to the power of minus 2, so u prime is going to be equal minus 2 y prime y to the power of minus 3. And as you can see, this, it's the same as this, so this quantity is going to be equal to minus 1 over 2 u prime, so it's going to be minus 1 over 2 u prime plus u is going to be equal to x. As I said before, we need to make this coefficient as 1, so by multiplying by minus 2, we're going to obtain y prime minus 2 u prime minus 2u is going to be equal minus 2x. So as you can see here, let's integral of minus 2 dx, so it's going to be exponential minus 2x. So by multiplying by exponential minus 2x, we're going to obtain exponential minus 2x u prime minus 2 exponential minus 2x u is going to be equal minus 2x exponential minus 2x times x. So as you can see here, this is the derivative of the product of exponential minus 2x, and u all prime is going to be equal x minus 2 exponential minus 2x. So by integrating both sides, we're going to obtain exponential minus 2x. Let's do the integration by part in this side. So what we are going to obtain, here we have x, here we have 1, the derivative of x is going to be 1, and the derivative of 1 is going to be 0. And we have minus 2 exponential minus 2x, and the primitive of this is going to be exponential minus 2x, and the primitive of this is going to be minus 1 over 2 exponential minus 2x, since when we get the derivative it's going to be the same, so it's going to be plus minus. So we're going to obtain, by integrating the both sides, we're going to obtain exponential minus 2x u is going to be equal to x exponential minus 2x plus 1 over 2 exponential minus 2x plus c. So by multiplying by exponential minus 2x, we're going to obtain u is going to be x plus 1 over 2 plus c exponential 2x. And u, as you know, that u is 1 over y squared. So we're going to obtain y squared is going to be, sorry, y squared is going to be 1 over x plus 1, sorry. Yes. So y squared is going to be x plus 1 over x plus 1 over 2 plus c exponential 2x. So by the square root, we're going to obtain plus minus the square root of 1 over x plus 1 over 2 plus c exponential 2x, and c belongs to r. So as you can see, this is some examples about some types of differential equation. I hope that you have understand. See you in the next videos.